So with this, I will let Mar do her presentation, I think mostly about the Rocketbox library, right?
Yes.
Yeah. Okay,
Thank you
so
so much, Nuria. It's a pleasure to be here. I would have loved to be in person, and I see there are quite a lot of people in person. It's getting to a point that when I try to give presentations, it becomes too broad. So I've decided to only talk about the libraries today. I think it's the most interesting for you guys, but I also don't haptics, locomotion, many things. And I feel like that's partially the beauty of VR, how many areas you can touch, how close to each other they are, right? Like if you're doing, like Ganelen was doing this space of interaction with crowds, then you can start thinking about haptics at the same time, about locomotion at the same time, right? Like everything is part of the same problem of having the user inside the content. And I feel like one of the issues here is how do we create this content, right? We need to have good tools for it, and libraries that are freely accessible. I think it's a way to superpower the community and bring more people to be able to work with things. So I've been working on this for a while. It's clear that once you are in VR, there are many reasons why you want avatars, right? You want avatars to represent other people, but also to feed your body into this embodied experience of having another avatar. And there are many capturing suits that will help you animate avatars too. And each one of them is a bit different. So the issue is that when you are looking at these super dense bodysuits, that is quite easy to do the remapping. Not everyone has that, right? So it's still very hard to animate the avatars even with that. And when I was at UCL, we built this experiment on concerns on the reproduction of a Milgram experiment in which a person has to electroshock an avatar, and just building the whole thing took 6 months, right? In a computer science department. So, and this is kind of more interesting even for psychologists than if you think than for computer scientists. There are some things that are just like incredible tools for other spaces on anthropology or sociology, and they just cannot even start using this. Or even like all these people doing body experiments, they still use mannequins and rubber hands. I'm like, how can this be, right? So that's something that it's kind of a bit of an issue. And then all the things that you want to do with simulations that require like avatars and things, that it's kind of hard to do if you don't have the assets, right? Like you have to start by having something. Otherwise, like the higher layer just like becomes impossible, right? Everybody's trying to solve exactly the same problem of the time. And that's how I found myself a couple of years back when I was at Microsoft, and I'd say, oh, I would like to use again these Rocketbox avatars that I used during my PhD. And then I tried to trace them back to buy the license, and I couldn't find them, right? The company had been acquired. And so and actually Anthony Steed was a visiting faculty at Microsoft Research for 3 months during that period. And that's when I found out that, oh, it was acquired by Havoc, and Havoc was acquired by Microsoft. So we must have them inside the company. Nobody's using them. It's impossible to license them because not even paying you can get them. So I started tracing back to see where they were. I think this idea of archaeology in computer science, it's something that is starting to be a real thing. So I found it, I cleaned them up, made sure that they were compatible with modern tools like Unity, etc. Then released the tool, right? And also for the release, I talked with a bunch of people to build this super wide publication that we did that's also cross industry, cross academia. It deals a lot with many of the work that others like INRIA or Max Planck or are also doing, right, in different areas. How this compares to the almost photorealistic avatars, etc. Right? So we were able to release this for academic and research use. Why is the video not working? Okay, well, this video is not working. You've seen the avatars, they're all over the place. Right now, a lot of people are using them. And initially, we released them only for academic and research use. But after a while, people started asking like, oh, how can I license for other things? And I asked some people at Microsoft and they were like, oh yeah, but it's too complicated. We're not gonna be licensing for. And then I was like, okay, we should just give them free, right, for everyone. And that's how we finally released everything. So one of the problems then became like, oh, what do we do with the animation, right? So I thought, okay, we can have a compatibility, and I started working on how do we add compatibility with animations that are out there, right? So there are videos on YouTube showing how you do it with Mixamo, with the CMU animations, and eventually I released also 417 animations that work with them, right? But this is, for example, a Mixamo animation on the avatars. We even release animals also. Sorry, I don't have animations for the animals. So the animations were also clean to be able to bring it out. And I'm very happy that we're reached a moment in which people are adding things, right? Like VR Luxor mockup. Well, the Mixamo, this one I added. How you bring it into Neos VR, how you import them into Carrara, you know, all sorts of things that I think it's like a bit, the one thing that you can do that will very much amplify your work is create something that more people can create on top, right? Do the things I don't have time to do. Eventually, we've done quite a lot of updates, and many of them have been on remapping tools of mockup, right? This is something I saw that people were not doing. It's a bit too hard sometimes to do it. You know, it's different to just be able to play animations, and the other one is to have real-time tracking or be able to create your own animation. So a lot of the, you know, since we updated to MIT license, which means you can also use for commercial, but also means that if you have a work that you have used the avatars and you want to release open source, you can do that too, right? I mean, I feel like it enables more open sourcing tools. So the first thing we did is actually to prepare this move box. I'll talk a little bit about it. Some other people were contributing like, oh, bring it to Unreal, or and then we released the head box, which was for blend shapes. And then we released these more animations, and Fangma and Sylvia Pang contributed recently, and we added the AR kit for the blend shapes. I'll tell a bit head box, because it's not just the animations or the blend shapes, it's also a tool that you can do your own blend shapes. So this was also actually super cool that somebody was already using the tool to create, you know, what we're gonna see is that there are gonna be new, better tracking systems coming out, and some of them might be compatible with the Rocketbox, so we just need to keep updating them, right? So let's talk a bit about the Movebox.
Realistic avatars are an essential component for creating social interactions in virtual reality. However, the main issue faced by small labs is a lack of simple self-creation animation tools. In this paper, we present Movebox, a plug-and-play toolbox that aims to provide resources for motion capture and animation of the Microsoft Rocketbox avatars without the need for professional equipment.
So this thing, once the move box is done, took me 15 minutes to, or less of 5 minutes to do. Compare that to the 6 months at UCL to build the Milgram experiment, right? It's like night and day. And so I'm gonna just, you see these blogs, I'm gonna talk about the blogs and how do they come together, right? A bunch of blogs, the GitHub tool here, you have it down here, but mainly we're using commercial, very, very cheap systems that you can use, like the Kinect, Azure Kinect or Kinect V2, and then remapping things. That's how it started, right? It sort of makes sense because at the time I was at Microsoft, so it was like, okay, we can use our own tools for this, right? Like it's just something that improves our product. But in reality, it's like 3 projects, right? One is this Capture Studio that you can use the cameras to create the animations that you replay later, and then you can create a whole scenario of people interacting with each other and all being recorded from your living room, right? There is another project that is kind of an embodiment based that you can have this first person experience. And it also includes IK and finger tracking with the Quest. And then there is this third project that is just like a parser from the simple models. And if you have this type of parser, then you can use tools that, this is something that is being pushed very hard from Max Planck, right? You can have tools like this Vive, and now they have new ones like the STAR thing. That you can use videos from YouTube to trigger your avatars, or eventually I think you could even use things like a body cam from a policeman to recreate the scene for people who do immersive journalism or things like that. So here is the link for this tool. The Capture Studio.
Using depth sensing cameras such as Azure Connect or Connect version 2, the toolbox can track a user's 3-dimensional motion and transform that data into a full-body animation clip, which combined with the basic analysis of an audio input, we can add facial animations so that the avatars are lip-synced.
Thanks to the bone structure on the face, we can animate the jaw for lip sync and add other facial animations such as natural blinks.
So here, well, 2 things. One,
using depth sensing cameras such as
okay. So the lip sync animation is just moving the jaw with the power of the signal of the microphone. I think we're over that now. With the Headbox, we give compatibility to other things. But the most important thing is how you can actually record and play back animations, right? So we're gonna go into that now. There are some issues also that happen, right? For example, with Kinect V2, it's thought to be just planar in front of the camera. It's not thought to be a 3D camera. So you run into issues like this, right? But you actually have the data model of how the arms should look like, right? Like there is no reason why you shouldn't correct for it. So we did a data-driven correction of the arms so they don't roll like this. And I think, this kind of small tweaks work quite nicely to make it easy. And then one of the issues what I haven't solved yet, or I think it will be easier to solve in a different way, but it's this idea that you need to remap, because every capturing technique or tool is going to have different bones. They're going to be oriented in different directions, and then you have to basically remap that in order for you to see an avatar that is not like all bended and broken. Oops. This is, so wait a second, before I go there, I want to show a bit of this again, right?
Toolbox allows for all of these features to be viewed and used in real time.
So you can...
Toolbox also enables resizing capabilities.
Let me see. Yeah. It's kind of not working the video. I'm not sure what's going on.
Toolbox also enables resizing capabilities. This scaling is done by measuring the foot and head joints using the depth sensing cameras, and then resizing the skeletal structure of the avatar accordingly. Movebox allows for all of these features to be viewed and used in real time, but also be recorded for use at a later time or with different avatars.
So you can replay another avatar while you record your new avatar. So that's kind of cool. And there is another thing is that you can crop, right, your animation a little bit. So you keep adding this avatar script to all the avatars and adding animations to them, and then you can eventually play this through the script system, right? So it's not using the animator tool from, actually this is built on top of the animator tool of Unity, right?
Toolbox also enables resizing capabilities. This toolbox also enables resizing.
So the parser that we were saying allows you to do things like this, right? So you have a video from YouTube, Vive will reconstruct the whole 3D, and that is what you transfer to your avatars. It's more tricky than you think. First, be careful because this video inference work, it's not, it's only for research. Okay, so they haven't released it for, it has a limited, you cannot redistribute, the license is not everything. And second, it doesn't work well if the camera is moving. And many of the videos on YouTube, the camera is moving. I think they have done new versions of this, and also the star data, it's probably a bit better than the simple for the parser, but they work very similarly. So I invite any one of you to fix it on the code if you wanna work more with that. It shouldn't be super hard. So we did a bit of performance validation.
We validate our toolbox using both the Azure Connect as well as the Connect version 2. As a demonstration of the animation process, we perform upper and lower body movements and are able to view the resulting animation of the avatar in real time. Due to the lower joint tracking accuracy of the Connect version 2, some joint rotations are measured poorly, the result of which becomes apparent when transferred to a full body avatar. To improve the Connect version 2 results, in Movebox we implemented a model-driven rotation compensation. The effect of a better machine learning tool, which is implemented on the body tracking SDK of Azure Connect, is seen consistently across various different kinds of motions. For example, the built-in neural network joint tracking solution allows the system to reconstruct motions where the user performs a full 360-degree rotation.
So you get this a little bit, and we
validation shows how Movebox responds to different depth sensing devices and how better machine learning systems are helping in democratizing motion capture tools and avatars for end users.
Well, you get the drill. You can have a big crowd. One of the things about this work also is for the embodied project, we implement it's a basic type of, but there is an inverse kinematics for the upper body, which I think it's one of the things that someone needs to solve, because everybody is using Final IK, and that really prevents us from providing like libraries open source, right? So, and it doesn't seem super complex, right? Like we did it for the upper body. The same thing can be used for the lower body, but you need to improve a bit if you do it with Euler angles. So, hey, somebody going to eating quaternions for everyone, and everybody's gonna use your tool, right? It seems like it's not super new, and I feel like there should be more space for open sourcing tools in our publication system, because it's not, right? People are like, yeah, this is just a tool. And you're like, yeah, it's gonna power so many people to do better research. It's important also, right, that we give a space for this. And in fact, I've been trying to have this open access to libraries, workshops. One year I did it in AI VR, and the other year in IEEE VR. This is a nice trick if you think there is something that the community should be publishing more, but you cannot get to publish anything. And I would say latency is another space where it's very hard to publish. Motion sickness is another one because everybody's like, oh yeah, but NASA did it and they had like 90 pages of it. Yes, but with a very old type of device, right? So we need to redo it, even if it's a smaller. So you build a workshop that is dedicated to something, and it allows you also to publish more of your own work in that space. It's not as prestigious as a full conference, but at least you get things out. Otherwise, like there is no space for like you know, the reviewers just burn you because like either you didn't have a proper study with it, that you're just like, oh, I have a bit of a performance study, or but you know, it's like it's a bit hard sometimes. So that's a trick you should use if you're in a space that is very hard to publish. Think of other people who are in the same issue, and they will come together and do a workshop, and it also makes more sense. Sometimes it's like a special issue, like this workshop you're doing here, right? It's bringing together a bit of that. So we moved into the Headbox. Was the next library that was very obvious we needed. Welcome to the Headbox. This is a toolkit to enable facial animations on the Rocketbox avatars. The demo that you're seeing now includes lip sync from the Oculus lip sync, enabled by blend shape biceps, and the open face for the rest of the facial tracking, including a bit the head movements, right? So I hope you enjoy it. There are many avatars you can use, and you can combine it also with the Movebox for recording of animations and replaying of animations. So that really creates a whole new space, right? Like the moment you can do a bit of facial animation. I'll talk a bit about what's left in here that I haven't have a time to do the same way that, you know, more parsers are needed for the Movebox, especially now that we have better AI that does like vision models of skeletal reconstruction, but how do you transfer that to the avatar, right? So the main thing about the Headbox is that we try to use this facial action coding system, which is kind of a standard. It's interesting because it's not based on emotions, it's based on muscle movements, right? So you're raising the lid, moving the cheek, and what is the effect on the face. And there is a bunch of work here. There is even a super long book on facial action coding units. And there are people who look at other people and they're like, oh, they're moving A1 and 20 and 11, right? Like they look at your face and they think on action units. And I'm not one of these people, but it's amazing to see them. So what we try to do is, because of the Rocketbox avatars have bones, we try to, through the bone system, create a way to make blend shapes and transfer them to all of the avatars, right? So you do a change in one avatar and you have it for the whole library. And that was the tool that Matthias was working on. I was trying to do something on a higher level with the animation when he reached to me. And I feel like most of the contributions that have happened, or my interactions with externals, have been because they've been trying to do something for the libraries. And for me, working on open source from industry, working on something that's going to be open source, is very clear you have no problem to work with an external, right? So I work with a bunch of people doing things that are going to be published later. So with the Headbox, we build this initially, the biceps, so you can have lip sync. It works with Salsa and it works with Oculus lip sync. And then the action unit, so you can have open face. We release executable of open face, but we couldn't release the open source. Again, same thing. I think the computer vision community needs to start Open sourcing tools, especially if they are not like the latest thing, change the license after they've been out for a while, right? It really like brings people to the next level. It also has compatibility with the bifacial tracker. It has a bit of custom expressions because at the end you can also trigger like, oh, I'm sad or I'm angry, or, you know, I know facial action units make more sense, but they make more sense for tracking than from like an emotion. Sometimes you just want to trigger an emotion, right? And as I say, this is very compatible with the move box for the rest of the body. So you end up having things
Hello,
like this.
everyone. I just wanted to say how happy I am that we are in this workshop promoting the use of open access tools and libraries for virtual reality. Have a great day.
So you remember I just played before the animation of the handshake, but now it has lip sync, right? And it changes completely. It's not just lip sync. It has a bit of
Everyone, I
a
just
bit
wanted
more,
to
right?
hello,
And if you have something that could be done that is very nice is to add a bit of facial idle animations. I had a paper on idle animations that is super beautiful because people are looking on a mirror, and if the idle animation is nice, they don't realize it's not matching their own animation of the face, but they are like, yeah, the face was super alive. It looked like my face. And you're like, yeah, but it's clearly not your, right? We didn't record anything from your face. But just the idea, I mean, unless you start smiling or crying or something that you're clearly not doing, but just be very saccade thing, very small motions. The blinking creates a lot of connection with the avatars. But I'm not here to talk a lot about that. So we created this expression creator, right? This idea that you go into through Python in Maya, you create this. Here you see it. It's just a box that will save and load join information, location, rotation, scale, and transfer it to all of the different avatars, right? So once you have a new facial blend shape, you can transfer to all of them. It works if you do blend shapes in the rest of the body, but they need to be triggered by bones. So it wouldn't work if you do vertexes like, oh, I want to build a heavier avatar or a fatter avatar or thinner, or like this would need something else. And that was what I was trying to build initially, more like a vertex morpher. And I mean, that's something that someone can do if you want it. People will use it, and I feel like you can do cool experiments with that too. This is how it works to use the facial expression creator. You download it from the GitHub. You can run the Python script in the Maya scene. You model the expression, you save the expression, and you transfer it to all the agents, and it's end up in the out directory. So here you see what, you would do this in Maya, like, oh, head is open, and then you just save it, right? That's there. You go back to neutral, apply something else, right? And you keep saving all of that. And then once you have all your animations, you hit these transfer blend shapes, and then they all appear on the output. So it's, again, it takes all of the avatars, and then now they all have the same blend shapes here, right? And they are compatible with Unity. Okay. So with that, we had a new contribution that is, okay, what if we build all the blend shapes that are needed for ARKit, right? And then you have this much nicer facial animation, right? It's using the ARKit from the iPhone, which is many times better than OpenFace, right? Like it has 52 blend shapes, and OpenFace, I think it's working with the like 10. So you see the difference. So one of the things that we're doing with Sylvia and Fang is trying to figure out how people perceive the different ways of using, like how much better it is one or another animation form as a contribution for the, like a validation of the headbox, right? Another thing, and you see, like once you start having these tools, like building more tools, it's like a natural disaster, right? Like it keeps having, you keep at it. So now that you have the avatars and the animations, and also we were able to import to Unreal with the work that Joachim did. Then you have these, I mean, and these animator controllers, you see here, you can add the animation and then just the animator of here, down here, I'm not sure if you see it, but this is being moved. So now you're going forward, you're running, and it's very smooth how it transitions the animations on the animator in Unreal. So you can go through the two sides and then faster, slower. And then you can also add interruptions, right? Like a person is running and something happens, and then you trigger another animation. So I feel like all of these tools are very nice precisely to do crowds. So we have been creating an API for people to create crowds that is quite easy to like all of a sudden have a bunch of people that avoid each other and or can have different personality here, like you can see here, like risky personality or like default. So the risky person will just cross when it's red, or like they don't care about some of these things. And we build a city life sim. We're releasing it. So far, it's more like an executable where you put this sort of API and then it runs. But we're planning on releasing the whole open source because it's built on top of AirSim, and AirSim is also open source, so there is nothing really stopping us. I left Eyal Ofek doing that as I'm leaving the company, but this is kind of what we built on the simulator, right? So the idea here is that you can have all, well, you create these sort of files in which you program many people to come around. And then there are special areas where we have done this in Unreal, right? And they have information about local pathfinding, like, oh, you should avoid this person. So if that's a repellent, there are blockers that will prevent you from passing before it's like correct. Or like if you put something, oh, somebody falls into the floor, you create a repellent there or a blocker. It has attractors that will kind of attract only one person, or attract people into a line if you're on a bus stop. And then if you have a bit of that personality, so what we evolve the personality is that every POI you have a probability of you being attracted to it, and some people just like don't get attracted to the bus stop, or you know, there are some people dancing in the street and some people just like don't want to dance with them, and others will go and dance. And you know, you can imagine many of these scenarios, you just build them and then drop the crowds and see what they do, right? The good thing about AirSim, and the main reason why I started working with AirSim is like AirSim is a simulator to do computer vision for self-driving cars and create synthetic data for them, right? Like, oh, we're gonna have snow weather, or like it's the middle of the night, and like you train the system with that, and it has like ground truth, right, of the pedestrians and things like that. But it didn't have pedestrians, right? Like you're training a drone or training a car, but you don't have pedestrians in the street. So I was like, oh man, we should totally put the pedestrians here and have them have like, you know, kind of weird behaviors, because most of the tools in the market, like Carla, you know, a pedestrian would never cross across the middle of the street. And that's precisely what you need to train the car for, right? If it's gonna be a self-driving car, they need to be used to their people doing weird things sometimes. we tested it with some tracking system. But the cool thing here is that you can, your simulation has a way to trigger things, and then you can you have this synthetic data creator, and the origin, your configuration file. If you change something, whatever change in the simulation is because you changed something on the configuration file, right? So you can have a causal model learning, which is something very hard to do just from brand out of the box camera video from the street, right? Like, why did something happen? And I feel like simulations have a lot of importance for synthetic data and causal reasoning. And I feel like there should be more link from the AI community to the tools that we build, because they don't have the computer vision people cannot do simulations well. So I feel like there is a long collaboration there that we should be exploiting more. And there are new libraries coming soon. I have work ongoing with Tiffany Do and Ryan McMahon in Florida. Same thing. They came like, oh, we're using this and that. What can we do this together? And it's kind of easier for me, or it was easier for me to do this. And same with Sylvia and Fang. They contributed the AR kit, but now we're like thinking of a cool experiment with it. That will validate sort of how much better this is than other forms of facial tracking, right? So there are new things coming soon, and there are a bunch of contributors in the end, right? That have been working on the different parts that have been released. Many of them are at Microsoft because it was easier for me to tap on them. But the others are like people who are building things that come later, like Andrea from Cornell and Cheng Yao, who say like, oh, we build a parser for the simple model. Okay, let's put it in, right? And so on, right? A bunch of these things. A few things that I wanted to mention that are missing, or that I feel like could be cool projects and not necessarily need me. One of them is this idea of a Frankenstein, that you can swap heads across avatars. I had it's not a hard problem. You can do it also inside Unity through the mesh vertex, because there are 3 materials, right? Like it could be in real time, like you just swap the head. There are 3 materials assigned, and one is to the head, which means they're like a different mesh, sub-mesh that is called, just for the head, right? Like you can just crop it. The thing is that when you bring it from another one, you also have the whole shader part and the mapping of the UV that needs to be done. Like it's not just transferring the vertices, it's just like there are more things you need to transfer, like the normals, so just it shouldn't be super hard, but I never had time to finish that. But I feel like that's powerful. And the reason why I didn't finish also is because there are different races, right? So, I mean, it was a bit complex to change the color of the avatars too. So that was a bit of one thing that I feel like could be a cool project. Another one is morphing, right, between 2 avatars. You can have you can just align the faces and then move the vertices to be closer to the other one, like have a ray tracing from each vertex to see where you hit the other avatar face. Like, it should be minimal, but then you can morph it, right? So even if you have like a lookalike system that creates, like Veronica Arballo has one that is very cool. And we actually talked about having something together in which you could have your own face into the Rocketbox avatars. Like this type of tools, I think on self-recognition could be super cool. And I've done some work on self-recognition, and definitely that was when I was still doing at the event lab, right, the electrophysiology, and you would see that the brain would respond differently, right? So I feel like there are these sort of hanging fruits that could really multiply the impact on the facial and also on the diversity. So there are only so many, like it's a diverse library, but it's not equally diverse, right? Like there still black doctors, there is only one and it's a male, right? And also like there is different ages, which I find it's also cool. Being able to age avatars on the face is also something that could be done with BAM mappings and like on the shader, applying it gradually as you want, like, and even like during the animation, I mean, this is done on some of the new super realistic avatars, right? But it can be done here too, right? It's in a more simpler way. But this idea that when you move this blend shape, you also add wrinkles in the head, or, this is not super hard also with a shader. And I have a part of it done. Some of these are kind of like a half a part of it. So if you are interested on any of these projects, reach out and we can think of how we can do some of it together. Although I'm kind of changing jobs now, so I feel like this is how far it goes in terms of my contributions to the Microsoft Rocketbox libraries. I know that because this is a workshop, there are a bunch of students here, so I want to talk a bit about this process, right? Like, you look at it and it feels like, oh, we've done a lot of things, right? And generally when you start something, you don't feel like it's gonna, like, first, every project feels like, oh, you're gonna make it to nature, or like if you do it well enough. And so the news is that it doesn't really depend on you to make it to a super top journal. But the good news is that the impact doesn't come from the very small increment. Is the sum of the increments is what it made the impact, right? Like this many libraries is what creates a body of this is solid work that I can use for many things, because there are like many parts that I can reuse or like augment. So think of in your particular areas, what are problems that you have that you think other people also have and would simplify their lives? Those are generally high impact spaces, right? Anyway, that's something I wanted to say to the students, because I feel like you have some years ahead and you can think of this type of, what I've done, you could do perfectly in a PhD, right? It's, okay, and I'm done with the presentation, but I'm happy to take questions on anything, the animations. Yeah, Christina Dobre is asking, how do I think facial tracking will work in VR? As parts of the face are occluded with the headset, and is there any way to reuse some of this work for VR? Yeah, indeed. So that's why I felt I was very interested on the idling animation part. But to do good idling animation, you should have like initially recorded maybe facial tracking from another tool. So if you have an AR kit, you record yourself, and then you have an idling animation system that will sort of trigger these things. Another interesting thing would be record the facial, record the audio, do a mapping of the two, and then whenever you're saying something, it would trigger this type of facial rendering. So the idling is a bit smarter. But yeah, certainly it's a bit of a challenge. That's, for example, the Vive facial tracking is something that we implemented into the blend shape. So that one, for example, works directly with the headset. So I do think that we need to have facial tracking in VR, especially as you are in front of a mirror, which doesn't happen very often, but in VR happens more often, experimentally, or talking to other people, right? And that's the other thing you could do, just add animations to the other people with pre-recorded animations, but you can pre-record your own, right? That's kind of a thing. Okay. Um, any more questions maybe on the audience,
Okay.
something?
I will have one. Hi, my name is Radek. I come from Max Planck Institute for Intelligent Systems, so I was happy to see that you actually use Vibe and Simple, or my colleagues will be even more happy when I tell them.
Cool.
My question is going to be more vision-based. Recently, I saw a paper come out of Microsoft. It was called Fake It Till You Make It. It was about
Yeah.
generating synthetic data for face-related tasks. It seemed like there was a very good face model behind it. I was wondering if these efforts are somehow connected, if this face model could be put into the Headbox library that you mentioned, or if it's totally separate.
Yes, that's where the morphine, my kid just woke up. The morphine makes sense, right? Because with the morphine, you can morph the vertices to whatever model. And I think that's something that will come soon. This is a perfect example of how important synthetic data is becoming, because labels are perfect, right? Even on the simulator that I showed you, we have better accuracy to know what thing, like you can have 1 pixel and know it's a human, but if you show 1 pixel on a labor, labeling person, they will never know that was a human, right? So I think you can have perception beyond human accuracy if you have good labeling, or like ground truth for the training. And that it's a combination, apart from, like, everybody talks about not having bias, having a better set of data, etc., which is true. But I also see a performance improvement when you use synthetic data, and the fake it till you make it, you see it perfectly. I have a message for you to send back to Max Planck. Can you
Okay.
make the old libraries MIT license? Not the new ones. I know there is it's an interesting effort that it also maintains the research, but the old libraries will also bring it. I think it's also an equity issue. I'm very concerned. I'm on the BGTC Diversity and Ethics Committee chair. BGTC is the technical committee at IEEE that oversees ISMAR, VR, VIS conferences. And I'm trying to have more geography diverse people in the space. And it's like there are parts in the world they cannot afford to pay for anything, right? So we need to democratize a little bit and be able to have more free libraries will help everyone.
I will pass the message to Michael Black. I have
Good.
no idea what the reaction is going to be.
I mean, you have already star model. Not even just like Vive. This idea that it's only for research makes it very hard also for other people to then release their research, right? And anyway, just pass it. Yeah, it's good.
I
Thank
agree.
you.
So to my previous question, you said that the fake it till you make it stuff will probably make it into the library eventually? Or...
If someone builds the morphine for the face, yes.
Okay.
Morphine means you have your vertices and you extrude them or intrude them
I
to match
that.
the other vertices.
So
I haven't been able to
done.
finish it. Somebody needs to do it.
Okay.
I've started it, but maybe someone in this room wants to do it.
Okay, thank you.
Yeah, I feel like many of the problems are a remapping problem at this point. Like, either remapping vertices or remapping bones, or, but they open many avenues, right? Remapping vertices would be fantastic because then you can also change the body shape, right? Like there are many things that are behind this idea of remapping the vertices.
Maris, Nuria here. So I was wondering, I mean, you did mention it, that you're now switching companies, so you're kind of, this is where your path finishes. But I was wondering, is there anybody at Microsoft going to continue with this effort? Because I do agree with you, it's super important to have these kind of libraries, these kind of tools to make students' life easier when they want to get started into a particular problem without having to deal with everything else that involves virtual humans. And as a matter of fact, this European project that we have, this CLIPE project, started a little bit with that goal in mind, being able to create tools to author and to edit and to model virtual humans in an easier manner. So is there going to be somebody else after you continuing the library, maintaining it alive? Because we're really running
Well,
alive.
I mean, as far as I care, Nuria, it could be you, right? It's open.
No,
Anybody
thank
of
you.
you can be that person.
No, thank
It
you.
doesn't need to be me. It doesn't need to be a particular person. I think that's the beauty of when you have these things, they come out and become something, right?
Well, one in between could be this. We have to talk. It could be. I mean, we have a lot of master's students that you were mentioning. Some of these topics as often are not interesting for PhD students because they, like you're saying,
Yeah.
many of the problems are easy to solve and they're not going to lead to a research publication. And when you're doing a PhD,
Yes.
that's your ultimate goal. But they could definitely lead to a lot of master's theses. So
Indeed, yeah.
yeah.
I mean, I do have some freedom in my new position to engage with externals, like in workshops or so on, that we can do. But it's certainly not going to be to power a product, like something that I released in my prior life. But I'm happy to help on these things. Another person that you can reach is Eyal Ofek.
Yeah,
I sort of given him the library.
okay, that was my question.
And he's a
initially.
great person that can help, but I'm not sure if he's gonna continue. I mean, I did almost everything myself, so he has contributed, of course. I have to contest a little bit what you say that is not interesting for the PhD students. I think because this unlocks a very particular experiment, if you're like, for example, I did my PhD on VR and clinical psychology. So I build tools to then study things. So if you think of it in this way, you can probably study things that no one else has studied, right? By liberating this new tool. And perhaps it's later the tool that opens a bunch of research that then follows your other study. And, you're kind of creating. So one thing that people want is that their work be relevant. And I think one way to do that is to bring more people to work in the same space. And that is important for a PhD student.
Yeah, at least
because they will want to be a professor later or something, right? This, or come to industry or.
And in terms of citations also.
Yes.
It
yeah,
usually
both.
helps. Okay. Any other question from the audience? No? Okay, so thank you very much, Mar, and sorry for
Thank
waking you up so early today.
No, it wasn't that early. Sometimes it's earlier.
Okay, we appreciate it.
It's
Thank
good.
you.
Bye-bye.
Bye-bye.